tough question. So I'd like you to proceed with the question. So this is 5, not fire. A 5-digit number, right, divisible by 3 is to be formed using the numerals 0, 1, 2, 3, 4, 5. So these are six numerals we have, and we have to form 5-digit numbers divisible by 3 without repetition. So this is important, you cannot repeat the numbers. The total number of ways in which this can be done is, so I know this is a little bit high level question, a little bit those who are not aware about the permutations, and I'm going to solve you, but before that I would like you to just give a try, pause the video, and just wait for wait for the answer if possible, and then check my solution. Okay, so I hope after pausing, so I hope that some of you have solved it. So let's start with the solution, right? So how this question proceeds. So we have a 5-digit number 1, 2, 3, 4 and 5, and we have 6 digits with us. So now for a digit to be divisible by 3, you must know this, already you know about it, that the sum of all the digits, sum of digits should be what? Divisible by 3, should be divisible by 3, then that number will be divisible by 3. So this have to be 1, so or n, so this have to be happening. So let's check what is there. So we have 6 numbers. So if we exclude, if we add 1, 2, 3, 4, 5 together, how much we get? We get 15, and this 15 is divisible by 3, right? So we see here is that this if you use all this 5, 1, 2, 2, 5, this is all divisible by 3, and any combination possible by this will be divisible by 3. So number of ways for using these 5 numbers will be, so we got the number of ways for first way by using all these 5 numbers is how much? Is equal to 5 factorial, and this is equal to how much? This is equal to 120 ways. Now let's consider 0 here. So if you use 0 in the beginning first, then this will become a 4-digit number, because you cannot use 0 in the first place. So you must use 0 in the rest of the places if you use. And if you want to include 0 here, so you have to remove one number from here. So let's talk about which number we can remove. So if you put 0 here, the sum of 0 will not change this any summation here. So if you would like to remove, you must remove 3, so that the summation of this have to be equal divisible by 15. So if you remove 3, the sum of this comes out to be 12 always, right? 12. How? See, if you put 0, 1, 2, 4 and 5, this is 5, 4, 9, this is equal to 12. And if you don't remove 3, if you remove any other, then the sum is not divisible by 3. You can check yourself. So this comes out to be that we have to remove 3 and we have to put 0, but 0 cannot be put on the first place. So how many numbers can we put on the first place? Only 4, right? And on the second place, how many numbers now can be put? So 0 here can be put, so here can be 4, and on the third place 3 and 2 and 1. This is equal to 4 into 4 factorial, and how much is this comes out to be? This comes out to be 96 ways. So total number of ways, this is n2. Total number of ways, n ways, that is equal to how much? n1 plus n2, that is equal to 216 ways. So this is the answer. So answer here is what? Answer here is 216 ways. So I want to introduce you this simple permutation questions. So I would like to tell you that permutations and combination not that much easy as you think. If you go deep in this subject, then the questions can be very tricky. So let's go to the probability part. This much permutation you should understand, and then you understand that why we use these permutations in the probability and combinations. So let's go to the question of probability here. So next question will be our probability question. So now we are going to discuss about the binomial distribution here. So as earlier we in the basics video I have talked about the combinations, and now I'm going to talk about the application using the binomial distribution. So as you have already heard, the binomial distribution is used in probability, and I generally don't want you to go for binomial distribution for simple questions, only for those questions in which the number of sample space, right, is large. Then we go for binomial distribution. uh, Generally no need to uh, remember anything here. It is just the basics that you already have done. So let's go to directly the binomial distribution. So what's there in the binomial distribution is, let's suppose a trial or an experiment in whose outcome can be classified as either as a success or a failure is performed, right? So let the number of parameters here. So let the number of sample space, so for let a coin be thrown. So a coin be thrown 100 times, okay, 100 times. So as you can see, 100 times is large number of uh, sample space. So here better use binomial distribution. And if very large sample space, then we are going to talk about the other distributions for that. So we have other normal distributions and other distributions. So basics, we are going to first start with the basics of binomial distribution here. So for that, let the n and then the here the number of sample space will be 100, right, because we have thrown 100 times the coin. And now p in binomial distribution is described as probability for the event to occur. Event. So let here the event we are talking about, probability of heads to appear, right, heads to appear. So p probability of head to be appear is 1 by 2, and q will be the probability of head not to appear, that is equal to 1 minus p, that is equal to also 1 by 2. Now this is the simple example of binomial distribution. In the binomial distribution we directly go to formula. So what they want to talk about is that probability for say in 100 times, say heads appear to be x, that is equal to say 40 times head should appear. So the probability of in 100 throws of a coin 40 times head to appear is equal to ncx p to the power of x, and इसके बाद q to the power of n minus x. This is equal to ncx p to the power of x 1 minus p to the power of n minus x, or simply ncx, n क्या है 100, c 40, p की वैल्यू what is half to the power of x की वैल्यू 40 and half to the power of 60. अब ये आप you can understand this we have already this अगर आप you go by normal method just that I have discussed in earlier questions, like say throwing of 10 dices, you can also simply understand how this formula appears, right? Because you have 100 events and we want to make 40 combinations of that 100 events in which the head have appearing, and then therefore we use nc x here, and then we use probability of that event to occur, that is 1 by 2, and this is 40, so 40 times, and the rest of the 160 times the head not to appear, the probability will be again 60. So same thing here by binomial distribution is indicated. So you then think why we need to remember this binomial distribution. There is one use of binomial distribution where the formula of binomial distribution, what you need to remember only is this part, that for binomial distribution we need mean. So mean, in mean we discuss binomial distribution mean, we discuss is that expected value of x. So this mean of binomial distribution is given by np. This is important to know. And the variance, right, variance that is sigma square, that is square of the standard deviation, that is equal to given by npq, or equal to np into 1 minus q. This is what I want you to remember, because this is used in various type of questions. When large variables are come, then you need this. So if you want to find out the mean here, say mean of this event here, so mean of this event x for say head, so head appearing if you throw 100 times, So the mean will be what? Expected number of times the head to appear. This is expected number of times of head to appear, right? Head to appear is number of times 100 into p, probability of head, that is equal to 50 times. So this is how we get the mean and variance. For variance, you do the similar way. You put that 100 into half, that is equal to how much? 25. This is the variance. This is variance. So what we have learned from binomial distribution is, what you need to remember is this. Rest you already understand how to solve, and this formula, I think because of the questions that you have practiced, you already remember this formula, how this formula has derived. So no need to remember this formula, or if you already just by seeing you understand how this formula is there. So you might have already in your mind now, but I want you to remember this NP and NPQ for mean and variance. Okay, so we'll discuss about the important questions in this binomial distribution. So let's go to the basic question, right? So basic question here is, so we have a basic question in front of you. See, the question says 100 dice. 100 dice means the dice that is numbered 1 to 6 used in Ludo. So 100 dice are thrown. Okay, 100 dice are thrown. How many expected to fall 6? So now you remember that why I asked you to remember that formula NP and NPQ here. It will be used. So how many expected to fall 6? Expected to fall 6. This is what they are talking about. EX, expected value, means mean. They are talking about mean. And what is the variance of number of 6s? So without that using that formula, you can solve it very easily. So this is a simple case of binomial distribution, right? So let's do that. Binomial distribution, right? So here the number of events is 100 and the probability for 6 p for 6 occurring is 1 by 6, and q here is how much? 5 by 6. So the expected number of fall of 6. So this is what they are talking about. Expected number of fall for 6 is how much? In 100, the expected value for 6 to appear is what? 100 into 1 by 6, because this is NP, right? So this is 100 into 1 by 6 will come out to be 16.7 or 17. So this is the answer here of first part. Let's talk about the second part. What is the variance of number of 6s? So variance of x, that is equal to NPQ, 100 times 1 by 6 into 5 by 6. So this value comes out to be 13.9. So this is the answer of the second part, right? This is second part answer. So I think you have understood it very nicely. So let's talk about the next question in binomial distribution. So we have question, very simple question in front of us, that 10 dice are thrown, right? And what is the probability of getting at most 2 6s? So as I've already discussed, what we have to focus more on, at most. So at most means ज़्यादा से ज़्यादा 2 6 होना चाहिए, इसका मतलब. So probability of getting there is for probability of this event, right, to occur is equal to, for the probability of event of 0 6s plus probability of event of 1 6 and probability of event of 2 6s. So here we use binomial distribution. For event of 0 6s, binomial distribution says NPQ, what is 10 p, and I want you to do, now be fast, NPQ. So sorry NCP. So what is NCP? P की value here is 0, so it's 0 into n p cube. This is very simple question. 1 by 6 to the power of how much? 1 by 6 to the power of 0 into 5 by 6 to the power of 10. Simple. Plus here binomial distribution, or simply without thinking of binomial distribution, you can also solve this 10c1, 1 by 6 to the power of 1, and then 5 by 6 to the power of 9. And then next question, this next part is 10c2, 10c2, 1 by 6 to the power of 2, and then 5 by 6 to the power of 8. This can be easily solved here. This comes out to be 5 by 6 to the power of 10 plus 1 by 6 And this 10c1, what is the value of 10c1? It will be 10 into 5 by 6 to the power of 9 plus 10c2, value of 10c2 is 10 factorial divided by 8 factorial divided by 2 factorial. 1 by 6 square, 5 by 6 to the power of 8, right? So this is the answer. You will see this in the options and you take it. So now you understood this, how to solve this question, and I will meet you in the next video with the better questions. So till then, goodbye.